Today we're going to work on our Phet Energy Skate Park lab. In order to get there, make sure that you click on your LCS links, go to Schoology. If it's not pulling up, just go to the right and sign in. Click on the first one or the link right here, and it should take you into Energy Skate Park. And there's 1, 2, 3, 4 different places that you can go. The worksheet should be here. In the pre-reading, it talks about kinetic energy being a type of energy of motion, while potential energy is with its position. So the higher it is, the more potential energy it has. Mechanical energy is the total energy of an object, or the sum of the kinetic and potential energy. The law of conservation of mass and energy, you'll hear that a lot even into high school, states that energy cannot be created nor destroyed, but it can be transferred from one thing to another. It means that if an object of a certain amount of energy, it will keep that energy unless the energy is transferred into another object. All right, so let's get into lab procedure 1. It says check the grid and box graph. So what you want to do is go into playground. If the box in the top left where it says energy is not clicked, make sure you click it so it opens it up. And the same thing with grid. In this one, you're just going to take and make your own skate park. Don't spend too much time on this. You're just having fun and exploring as it's asking you to do. Notice what's happening to the energy as your skater's going up and down your ramp. It says in number 2, explore the simulation. Try various track designs. In the top left corner, observe how the skater's potential and kinetic energy change and as he moves. Record your initial observation here. So what happens to the skater and the energy as the skater moves? All right, number 3, switch to the U-shaped track. Drag the skater to the top of one side and let him go. Observe the energy bar graph as he goes back and forth. You may also want to explore the W-shaped track. To do this, I would click on the intro, grab your skater. Again, make sure your energy and grid lines are turned on. And what they want you to do is drop the skater in. And they want you to observe the energy in the bar graph. You're looking at this section right here. If you want to go to the W-shaped one, click on the W-shaped one and drop the guy in. And again, you're looking at your energy and what's occurring. All right, we're going to pause that. Question number 3A. When does the skater have the highest potential energy? So you're looking for the highest potential energy. When does this occur? And you notice right now it's occurring as the person is the highest point on the graph. You can check that by going to the U shape and putting them up there, or seeing if they're at the bottom. When does the skater have the lowest potential energy? Again, you're looking at the point when that's the highest potential, and that would be the lowest potential. If you need to, you can always pause just to make sure that the skater is at the highest point of the ramp or the lowest point of the ramp. Also, when does the skater have the highest kinetic energy and the lowest kinetic energy? So write down what position on the ramp. Number 4, while he is moving, change the mass using the slider on the right and observe the energy graph. You're going to go to the mass and increase the mass size. What effect does it have over here on the energy? If mass increases, what happens to kinetic energy? So as you increase the mass, what happens to the moving energy? Does it increase, decrease, or stay the same? Number 4B, if the mass increases, what happens to the potential energy? Okay. Like it says, move up and down the mass and see what's happening to the kinetic and potential energy. You do that right here in the slider bar. If mass increases, what happens to the mechanical energy? If you forget, mechanical energy is the total energy the object has, or the sum of the kinetic and potential energy. You'll write down what is happening to the total energy. Complete the table. At the position of the top, take your skater and put them at the top. What is the kinetic? Does it have high kinetic, low kinetic, or medium kinetic? And then also, does it have high potential, low, medium potential, or low potential? Then put the skater in the middle. Does the skater have high moving energy or kinetic energy, or low kinetic energy, or medium kinetic energy? Same thing with potential energy. Is it high, medium, or low? Just look at the bar graph. Then take the skater, put them all the way at the bottom. Does the skater have high, medium, or low kinetic energy, or high, medium, and low potential energy? As you are doing this, make sure that they're moving, otherwise it's not going to show you any kinetic energy. All right? So make sure that they're playing because you can't just move them. All right? Now you're going to circle the correct answer. 6A, as the skater goes up the hill, his kinetic energy increases, decreases, or stays constant. As skater is going up the hill, what's occurring to the kinetic or moving energy? 6B, as he goes up the hill, his potential energy is doing what? So as the skater is going up the hill, what is happening to the potential energy? Again, make sure you're looking over to the left. As the skater goes down the hill, what is happening to the mechanical energy? Now, if you forget, the mechanical energy is both of these. So what's happening to both of these as the skater is going up the hill? Same thing, but in reverse. What is happening to the skater as he's going down the hill? So as the skater is going down the hill, what is the potential energy doing? And what is the kinetic energy doing when the skater goes down the hill? What is the relationship between potential and kinetic energy? So what do they do when one's going down the hill? What's happening to one of them? What is happening to the other? Question number 8. What evidence from the simulation supports your claim in question 7? This is an important question that hopefully in science you see more of. Is you're going to say or talk about the graph. What is the graph showing you about the potential and kinetic energy? Number 9, check the speed box in the upper right corner. What is the relationship between speed and kinetic energy? You're going to click up here where it says speed, play your simulation. What's happening as the skater is going down the hill? What is the speed doing? And number 10, what happens to the total mechanical energy of the skater as time passes?